I believe this is right around where we left off yesterday. We were talking about excessive superheat. Okay, shows us that an evaporator is not fully charged. Okay, it's just something to remember. Excessive superheat, if it's a fixed metering device. Okay, fixed metering device, that will be a cap tube or a fixed orifice. Excessive superheat is an indication of a leak because there's a shortage of refrigerant. Okay, if it's a TXV, we do not charge or measure by superheat. We use subcooling, different story. But for the purposes of the EPA exam, excessive superheat in a high-pressure capillary tube system is one indication of a leak. Okay. Although people who service Type 2 stationary refrigerant recovery appliance must own active recycling and recovery equipment, it is no longer required that the purchase of such equipment is reported to the EPA. This is a change from people who had studied for the EPA for the prior test version. Okay, you do not anymore have to report the purchase to the EPA. Okay, you still have to own active recycling or recovery equipment. Okay, in other words, you can't use passive recovery devices on Type 2 appliances. Okay? Before you recover refrigerant, you must determine the maximum amount of refrigerant that is contained in the system. That will be the system's total charge. Okay? I have to know how much refrigerant is in there before I recover it because I have to make sure my recovery cylinder has enough room in it for that total charge. By the way, I think we're around page 21 in your manual, someplace right around there. If the total charge is greater than 15 pounds, system-dependent or passive recovery devices cannot be used. Okay, as EPA regulations prohibit their use when the appliance contains over 15 pounds of refrigerant. The majority of residential systems, the majority of commercial systems are running over 15 pounds of refrigerant. Or right there. You don't want to use a passive recovery device in this situation. Okay, so if the total charge is greater than 15 pounds, you cannot use passive recovery. So if you look at the label there, just by the label, could you use passive recovery on that system just by the label? Anybody?
Yes. Yep.
Yes. However, if all of a sudden you have 25 foot of line set, that line set has additional charge in it. Okay, so you might be pushed over just by line set. Okay? Guys, you do not want to sit here for the 7 hours it's going to take to use the passive recovery. Okay? So we're talking EPA regs, but not what you would actually do. Before using a recovery unit, I'm going to have to mute people here. Okay, before using a recovery unit, we want to check the service valve positions. We want to check the recovery unit's oil level if needed. We want to evacuate and recover any remaining refrigerants from the unit receiver. Most of the newer systems don't have its little own receiver in it. Okay, so again, we want to make sure we don't mix refrigerants. So make sure there's no refrigerant from another system left over in your recovery machine. Okay, the older recovery machines, the ones that weighed a ton, had its own receiver in it, and you used to have to make sure all the refrigerant was out of that as well. Now, for the yellow ones and the newer ones, you don't even have to worry about that anymore. Recovered refrigerants may have contaminated impurities of acids, moistures, and oils. Okay, make very sure that you've recovered all of the moistures and everything, all of the oils and everything out of the machine. Even if you have to flush it with nitrogen, make sure that machine doesn't have contaminants in it. Okay, because if you've had a burnt out compressor, you're going to have a lot of acids and moisture in that system. Okay, you want to make sure that we flush these machines out. Okay. How do you flush a machine out to get rid of debris and stuff like that? What do you use? Anybody?
Nitrogen.
Nitrogen, yes. Okay, gauge hose is used to connect the recovery unit to the tank. And for all field service work, have to have self-sealing connections or hand valves to minimize refrigerant release when the hoses are connected and disconnected. You got to use valves, got to use low-loss fittings. Okay, that's required by law. You should be using them anyways, but use low-loss fittings, use valves. Try to minimize the loss. I really like the valves on the end of the hoses. That's what I use. But everyone likes a little bit of a different thing, so that's fine. Before transferring refrigerant to an empty cylinder, the cylinder should be evacuated to reduce pressure and remove non-condensables. Folks, before you use a new cylinder, throw it on a vacuum pump. Most often they do come in a vacuum, but if they're not, and if you have any doubt whatsoever that there's air in the system or in the tank, put it on a vacuum and let the vacuum run for a while to remove the non-condensables, remove the air, remove the moisture, and also reduce the pressure. The lower the pressure in the recovery cylinder, the faster the refrigerant recovery is going to be. Okay, so just get the air out of the system, get the non-condensable out of the systems. Before recovering refrigerant in a parallel pipe compressor, make sure that the equalization connections between the compressors are closed. Okay, guys, this is something we really haven't talked about. This is a supermarket rack system. Those of you in York have definitely seen this before because you have one in your shop. Okay? For everybody else and for the guys in York who haven't looked closely at that system that you have in your shop, between every compressor in the rack system, there's an equalization line. Okay, I've just drawn a light blue highlight on where it's at. Okay, what that does, it allows oil and pressures to equalize between the two compressors. Okay, they're piped in parallel. So every compressor running adds to the total output of the system. But in order to equalize, and to make sure that we have oil flow and everything like that, there's an equalizer valve between the crankcases of these compressors. Okay, it's very important when you're recovering from one compressor. Let's say this compressor on the right is dead. Let me change my pen color. Okay, the compressor on the right is dead. You're having to change that compressor. So you actually have to close the shutoff valve that's on that equalizer line so that you can just recover refrigerant from this one compressor. Okay, because in a supermarket rack system like you have here, you don't shut down the entire thing to work on one compressor. You're only shutting down the compressor you're working on and you let the rest of the system handle the load. Okay, but you have to close the valve on that equalizer line because you can't recover refrigerant from a single compressor unless it's completely isolated. Does that make sense? Any questions on that? Okay, this is a supermarket rack system or a parallel rack system. Okay, 4 compressors, they cycle on and off with increases and decreases in load. All controlled by computerized controls or tons of relays. They're awesome systems to work on, but again, you can never shut the entire thing down. There are recovery machines out there that use a water-cooled condenser. Okay, these are for majorly large systems, not something you're going to carry in your truck. If you ever have a recovery machine that uses a water-cooled condenser, they're generally connected to the municipal water supply. In other words, whatever the building water supply is, okay? Water-cooled condenser. They're connected to the municipal water supply, okay? They don't recycle water. They basically use it and dump it. To reduce recovery time, connect one of the service hoses to the liquid line and recover refrigerant in the liquid phase, or remove the refrigerant from the condenser outlet when the condenser is below the receiver. Guys, that last statement is extremely important in here.
My sleeping schedule's fucked up, yeah, I swear to God.
Okay, this last statement's extremely important. This is on your test. If the condenser outlet is below the level gravity-wise of the receiver, remove the refrigerant from the condenser outlet. Otherwise, remove the refrigerant from the liquid line. Any questions on this slide?
I'm trying to picture that. So,
okay, let's see if I can draw one of my stupid little stick diagrams that never looks good anyways. Okay, we have a building, okay? We have a mechanical room near the top of the building, okay? All of my compressors and everything else is there, up here in the top of the building, okay? My liquid line, my receiver, everything is in there. Because of high wind conditions or some other reason, they didn't put the condenser on the roof. They put the condenser on the ground outside. Okay? My condenser may be down there, my compressor's up there, my receiver's up there. All I have down here is a remote condenser with a fan. My condenser is now down below the level of all of the rest of my system. So the liquid refrigerant, because of gravity, is going to want to sit down here at the condenser. Does that help?
yes. So, yeah, so then you would remove the refrigerant from the condenser.
From the outlet of the condenser.
Okay.
Because the outlet of the condenser, it's a liquid phase, right?
Yep.
Yeah. Okay, so again, think about gravity. We want to remove the liquid refrigerant from the lowest point in the system.
Makes sense now. Thank you.
Okay. After the liquid has been recovered, the remaining vapor is removed by the recovery system. Your recovery system is, especially the newer recovery units, they're always going to want to remove the liquid first and then the vapor. Okay? Recovering refrigerant in the vapor phase, although slower than the liquid phase, will minimize oil loss. So if you're worried about losing oil out of a system that's notorious for, and you know these systems when you're in the field, but if you're worried about losing oil, then you recover in the vapor phase. It's a much slower process, but it pulls less oil out of the system. Okay? And again, gravity takes into account here. Oil will follow gravity. Refrigerant that has been recovered from an air conditioning system and held in a refillable cylinder may be charged back into that system after the repair. Okay, in other words, if I'm making a repair, if I'm changing a metering device, I'm changing a filter dryer, I'm changing something like that, I'm allowed to put that refrigerant back into that system. Where's one time you do not want to reuse that refrigerant?
If the compressor was burned out or it's contaminated with other refrigerant.
Yeah, if I have any contamination, if I have any acid, if I have any compressor burnout, I definitely want to replace that refrigerant. I don't want to take a chance. Because if there's acid in it, that new compressor might have a lifespan of a year. If the appliance is being disposed of, okay, you have to keep records for 3 years for each appliance being disposed of if the system's refrigerant charge is between 5 and 50 pounds. So in other words, if your service company you work for pulls out a system, okay, disposes of an R22 system when they put in an R410A system, they're required to keep the records for 3 years for each appliance being disposed of, basically how much refrigerant was recovered of it, and what was done with the refrigerant, and what was done with the appliance. 3 years.
Chris, I just have a quick question. It might be a little off topic, but where would somebody go take like a window unit that they want to get rid of? Like, I mean, you're disposing of that. It's got the refrigerant in it. You can't just throw it away.
Well, believe it or not, and this is very dependent on what town people live in, okay, and what area you live in. A lot of times, if you go to the landfills, okay, they actually have a special spot where refrigerators, window units, and stuff like that go. They actually pay somebody to come in with a truck-mounted recovery system, and they recover that refrigerant. If you live in a town where you just put it on the curb, supposedly the same thing is happening. It goes to the landfill area, and they're supposed to recover the refrigerant out of it. Do they? I don't know, but that's what they're supposed to do. I had a group of students, maybe when in my first year teaching at Porter & Chester, what is that? That's close to 15 years now, that actually went around the city of Hartford every fall. And it was a night class, so I had them for about a year and a half. They would go around the city of Hartford like on garbage pickup day, and in the fall, they picked up all the window units that were out on the curb. They actually brought them into the shop and spent a lot of time cleaning them and refurbishing them, and they sold them to people the next summer and made a lot of decent money from it. Okay, and the reason was because half the Windows units being tossed out still work. They just need cleaned. So, don't know if you can get away with that anymore these days, but it still sounds like a pretty decent little gig to me. So.
Thank you.
Okay. So again, what was that?
Or I was just curious if you have like a recommendation of some type of coil cleaner or something that you can use on like portable and window AC units. That
you know what the best coil cleaner I've ever used, and I still use it to this day, is Simple Green.
Oh yeah, that sounds great.
All right.
Simple Green is the best coil cleaner I've ever seen. Barry, you're on the call someplace here. What have you been using lately?
Simple Green, and also can't think of the brand name, but it's a foaming cleaner. But
yeah, like
that's very abrasive.
It's like nickel safe or something like that.
Yeah, but I mean you have to be very careful with the mix. It'll melt the coils.
Renews? Is that the one you're thinking of? Renews?
That could be it. Yeah.
Yeah, Renews will take the paint off the side of someone's house. I know that from experience.
Yeah.
You can get Simple Clean at the dollar store. Simple Green.
Yeah, Simple Green works really, really great Hey guys, I have a ton of background noise. Simple Green works really, really great. The other one that I've used lately, because I sort of like the spray bottles that you attach to the end of the hose it comes in, there's a cleaner you can get at Home Depot. It's more designed for not siding, but it's more designed for like shooting 50 feet in the air to get the windows. It's more of a window cleaner, but it's also classified as a building cleaner. I've used that a few times recently, and I sort of like that stuff. But Simple Green is my real go-to, okay, for coil cleaners because it doesn't do a lot of damage. A lot of these other cleaners that are coil cleaners, they're so strong they'll take the paint off the side of houses, and they'll also take the paint off the coils, and I don't want to do that. Okay, so moving on here. Hopefully I answered that question. The other thing you can do to speed up the recovery process is you can cool the recovery cylinder. Refrigerant really likes going to the colder location. Okay, refrigerant will always flow to a cooler location. So if I cool the recovery cylinder, like putting it in a bucket of ice, okay, I can actually speed up the recovery process. Because keeping that cylinder cold lowers the pressure of that refrigerant in that cylinder, and the recovery machine has to overcome less of a pressure differential. Okay, in addition, I can add heat to the system itself to speed up the recovery process. In other words, if I heat up the refrigerant in the system, I now increase the pressure differential between the tank and the system. Okay, so again, as long as I have a very big pressure differential between the tank and the system, the larger that is, the faster the refrigerant is going to want to flow into the tank. How would I heat up a system? What's the easiest way for me to heat up a refrigeration system that's installed in somebody's house?
Leave it outside.
Am I going to pick up the entire evaporator coil and move it outside?
With a blow dryer or something?
You guys are overthinking this. How can I heat up an evaporator coil that's sitting on top of a gas or oil furnace?
Turn the heat on.
Turn the heat on. Turn the heat on. Easiest way to deal with it.
What if the person has a coal furnace?
Turn the heat on. Yeah, I mean, again, I've never had to do it, quite honestly, but that's the easiest way to deal with it, okay? Again, the warmer the unit and the colder the recovery cylinder, the better off we're going to be. Okay, the amount of refrigerant in the appliance, you got to, as it drops, you got to be careful to closely monitor the temperature of the recovery unit's compressor. Okay, remember, anytime we have a compressor, the flow of refrigerant through the compressor is what cools it. So if you have a 100-degree day and you're outside running a recovery unit for a couple hours, as that system starts pulling into a slight vacuum, your recovery system compressor is not getting a ton of refrigerant moving through it. It may start to overheat. You might have to say, okay, we have to let it cool down for a little bit and then turn it on again. Okay? The flow of refrigerant through these compressors is what cools them. Now, the newer recovery machines, for example, the yellow one that I keep showing you, made by EPA, those don't have the same, they basically don't have the same type of compressor. It isn't a hermetic compressor. They use an external drive compressor, so it isn't as big of a problem. But some of the older recovery machines have a standard compressor in it. As the flow of refrigerant slows down, that compressor is going to start overheating. Just be aware of that. Okay? Be careful to closely monitor the temperature of the recovery unit's compressor. Again, if it's in red, may want to know it. In addition, the motor winding of a hermetic refrigeration compressor, that's air conditioning as well, can be damaged if energized under a deep vacuum. So care should be taken to avoid energizing any compressor in the system when the refrigerant is being recovered. How do we prevent people from energizing compressors in a system when you're recovering the refrigerant? What's the easiest way?
Lock it out.
Lock it out and tag it out. There's a disconnect near every air conditioning unit. Lock it out. Okay? It's for your own safety as well. Okay, we have required evacuation levels. That's required how low we pull the pressures in a system that we're required to have during recovery. Okay, these are EPA regulations. There's a table, I believe it's on page 22 of your manual. Can somebody tell me if that's actually where it is?
Correct.
Okay, this table, guys, this is just another one you need to know. Okay, there's no easy way to tell you how to memorize this. Okay, they're going to try to trip you up on this. This table is for all type 2 appliances except for small appliances, motor vehicle air conditionings, and anything that is mounted on transport refrigeration. Okay? There's no other way to tell you this. If you're highlighting, highlight this entire chart. You need to know it. 0HG. What is that? 0HG. What type of pressure is that?
Vacuum. It's inches of mercury column.
Yeah, but 0. Am I in a vacuum or I am just at room at standard pressures?
Isn't that almost a perfect vacuum?
Anybody have a gauge in front of you?
No.
29.9 inches of mercury is as low as my gauge goes. If you look at your low pressure gauge, you'll see that 0 inches of mercury and 0 psig are at the same spot. Okay.
So it's normal pressure.
It's normal pressure. It's room pressure. Atmospheric pressure.
14.7.
Okay. What was that? Yeah,
14.7.
Yeah, 14.7 psia. Okay. So be very, very careful about this chart because they are going to ask you. Okay. High pressure appliance. Give me an example of a high pressure refrigerant. Anybody?
R22?
How about 410A?
That works.
Okay. R22, it's falling very close to the medium pressures. Look at the top of your refrigerant chart that's at the end of this manual. I'm pretty sure, if not positive, that it tells you the different pressure classifications.
Also in the manual it says in example 1 below this chart, before making a major repair to an R410A, in quotations, a high pressure. Yeah, there you go.
There I go. Okay. 410A system, it's a high pressure refrigerant, contains more than 200 pounds of refrigerant. The technician must evacuate the appliance to a minimum vacuum level of at least 10 inches mercury of vacuum. Okay? More than 200 pounds of refrigerant. Let me tell you, that is a large amount of refrigerant. Okay? But because it actually says in here, or a component thereof. In other words, if I have a supermarket rack system running 410A, which I just don't understand why I would have, and if I just need to replace one compressor, I'm not going to evacuate the full 200 pounds of refrigerant. I'm just going to evacuate what's in that compressor. But I have to evacuate it to 10 inches of mercury. Okay, pretty direct and to the point. Okay, after reaching the required vacuum level on an appliance, you have to wait a few minutes to see if the system pressure rises. Okay, you can't just say, cool, I'm at 10 inches of mercury, I can remove my gauges and open the appliance to the air, because there might still be refrigerant. You have to wait to see if it rises. You're doing this for two reasons. One, to see if there's a moisture or a leak, okay, and two, to make sure you don't have any more refrigerant in it. If the pressure rises, you have to start the recovery process again and get that pressure back down so it holds. If it keeps rising, there's a leak in there someplace. Another example, when changing out a compressor of a system containing 40 pounds of R404A, which is a high-pressure refrigerant, evacuate the isolated section to 0 psi. If the system pressure doesn't rise after a few minutes, you can remove the compressor. Again, because it's under 200 pounds, we're now at 0 psi. Does everybody understand the change there? The difference in, it's based on the weight of the amount of refrigerant that's in the system. If leaks in an appliance containing a regulated refrigerant make recovery to the prescribed level unattainable, the vacuum levels in the chart can be ignored as system refrigerant only needs to be recovered until the system's internal pressure reaches atmospheric pressure. In other words, if you have a leak, okay, and you cannot pull a vacuum on a system with over 200 pounds of refrigerant in it, all you can do is get it to atmospheric pressure. It's the best you can do, and the EPA acknowledges that. You can't pull a vacuum on things that leak. Okay, easiest way to know if something leaks. You can't pull a vacuum. The refrigerant receiver will typically be found in the liquid line at the outlet of the condenser when the system uses a TXV as its metering device. Again, in a lot of systems with TXVs, you have a receiver. The receiver holds a large amount of refrigerant. You can actually use the receiver sometimes to evacuate the refrigerant into. When the system is operating, the state of refrigerant leaving the receiver is a high-pressure liquid. We talked about this. It's still on the liquid line. Comes out of the condenser, goes into the receiver, which is a storage tank for liquid refrigerant. It ensures that the TXV is getting complete liquid refrigerant. Prior to opening a system with a liquid line receiver for repair, the refrigerant should be pumped down and isolated in the receiver whenever possible. I can close the valve on the receiver, and I can actually isolate the refrigerant into the receiver. Most receivers are sized so that you can fit the entire charge of the system into the receiver and the condenser. Okay, and I could just valve it off, run the compressor until my suction line is down below 0, and I have all of my refrigerant in the caught between the receiver and the compressor. Okay, in other words, liquid refrigerant all the way back from the receiver. Any questions on that? A moisture indicating sight glass is used for checking refrigerant for moisture. Does it say any place in here checking refrigerant for a charge? To see if it's charged properly for the sight glass? The sight glass is, yeah, it doesn't. Okay, cannot use a sight glass to charge a system. It's strictly for moisture. The sight glass is generally located in the liquid line immediately downstream, which means after the liquid line filter dryer. By the way, notice the arrows on this. That's the direction the refrigerant is flowing. Or should be, unless someone put this in backwards. Okay. Anytime a system is open for service, the liquid line filter dryer should be replaced. The filter dryer is used to remove moisture from the refrigerant in a system. Okay, this is another type of filter dryer here. Okay, this filter dryer over here has a changeable core in it. You don't replace the entire filter dryer. You just evacuate the refrigerant out of this. You can't see it, but there's an access valve on the top of this. You valve this off, so there would be a valve there, there would be a valve there. You valve this off, you recover the refrigerant out of this, and then you can unbolt the top of it and pull the core out of it. Okay, this allows you to remove to just change the core. This type of metering or the filter dryer here, I actually have to braze in and out. So I try not to open refrigerant systems as much as possible. Okay, that's why a lot of times in our shops we put in filter dryers that have flare fittings on them, because sooner or later you're going to run out of line set to braze these into. Okay, two different types of filter dryers, same basic thing. This is more often the type you'd find on the suction side as a cleanup filter dryer. Alcohol spray should be used to remove ice from a sight glass or a viewing glass. So if there's actual ice buildup on a sight glass, you can spray it with alcohol or dump rubbing alcohol on it. Don't use hot water. It has a chance of cracking that sight glass if it's too cold. In the suction line, at the outlet of the evaporator, there's a suction line accumulator. I showed you this on another diagram. They're located between the evaporator and the condenser. The suction line accumulator has one purpose in life, and that's to make sure that there's no liquid refrigerant going to the compressor. Okay, so the liquid falls to the bottom of it, and we pull the suction gases from the top of it. All it does is ensure that there's no liquid refrigerant going to the compressor. But it does hold refrigerant, so you have to be aware of this when you're recovering. Accumulators. Again, as I just said in the prior slide, prevent any liquid refrigerant that may flow from the evaporator to the compressor. We've talked about three-way valves. We've talked about some shutoff valves here, okay? There's a couple different types of it. But a three-way valve, the normal operating position is back-seated. And I showed you this diagram the other day. Normal operating position is back-seated. My service port is here. That's where my gauge hoses go on. Okay, by back-seating, in other words, the stem is all the way out, I'm blocking the service port, but I'm leaving everything else open for refrigerant to flow. Okay, again, here, service port. Okay, here, service port. Notice the caps on these service ports. You always want to have things capped. Okay, but based on where the valve position is, I'm either blocking off the line port, the service port, or I have everything open. Three-way valves. In the back portion, a back-seated position, the gauge port is closed off so the manifold can be removed from the valve without releasing refrigerant. Any question on three-way valves? There's going to probably be about 2 or 3 questions throughout the test on three-way valves. Back-seated is normal operating position. On the high side of the compressor, on some compressors, especially semi-hermetic compressors, the discharge valve can be found. As with the suction valve, the normal operating position for the discharge valve is back-seated. Under no circumstances should the discharge valve be closed on an operating compressor. If you close the discharge valve on an operating compressor, in other words, if you front-seat it, the compressor will actually break down inside. All the valves, pistons, and everything else will break, and it has the possibility of actually sending them through the compressor walls.
Oh, siapa aja dulu.
Okay, let me mute somebody yet again. Okay, don't front seat the discharge valve on an operating compressor. Okay, for those of you who I worked with in the shop in York, when we were looking at that big semi-hermetic three-phase compressor for that, for the 6-door reach-in there, the supermarket reach-in that's in the middle of your shop, one of the things I did before we powered it, I personally went and checked to make sure that discharge valve was open. Okay, you don't operate a compressor with the discharge valve closed. To prevent compressor damage, refrigeration system must be protected by a high-pressure relief device, which may be in the compressor or it's an external relief valve. When using multiple pressure relief valves, they can only be installed in parallel. Okay, look real close at this picture over here. I'm going to circle 2 pressure relief valves. Notice they're installed next to each other. They are installed in parallel. By the way, this is a big chiller barrel. This is probably maybe a 200-ton system here. Big chiller barrel. Insulated completely. You can't see the metal. All you can see is the piping connections. There's a filter dryer down here at the bottom. Okay, and there's other connections going to my evaporator, there's probably a big compressor motor over here, a centrifugal compressor that has a drive motor on it.
Where does the material go when it leaves the pressure relief valve?
Into the atmosphere. Remember what I said? If you ever have a refrigerant leak, get out of the area.
Yeah.
This is a classic example of it. Okay, relief valve should never open. Okay, there's something bad that's gone in here if a relief valve opens. Okay, but it's going to save a compressor. How much do you think a compressor like the one on this system in the picture costs?
$20,000?
Easily. Easily. Okay, they're built specific to the job, and usually it involves knocking down walls or ceilings to bring the new compressor into the machine room. Okay, so this is a major issue. So if I have to let out 200 pounds of refrigerant and evacuate a building, it's much better off than having the chance of having that compressor blow out on me. Okay, so again, we protect it either internally or externally with the relief valve. Most of the hermetic compressors that you work with, that's the smaller ones that are used in commercial or light commercial refrigeration and air conditioning, that relief valve is going to be internal. Okay, it's an internal relief valve. Okay, crankcase heaters are used on refrigeration and air conditioning compressors to reduce the amount of refrigerant in the oil and to reduce oil foaming, which occurs in the crankcase on startup. Okay? We reduce the amount of oil in the refrigerant that's sitting in the refrigerant in the oil that's in the compressor. It's a crankcase heater. There's 2 types. There's one type that goes in a compressor well, that's up here on the top left, and there's another one that straps around the bottom of a compressor. These are energized either always or they're energized on the off cycle. In other words, when the system is not running. Be aware, there's energized components there. You can get shocked. If a strong odor is detected during the recovery process, in other words, if you smell sort of nasty Combination rotten egg, burning electrical smell out of the oil. Okay, or if you have some severe foam, that's not a white-colored foam, it's an off-colored foaming in the oil, there's a compressor burnout that either has occurred or is starting. You got to take an oil sample to test for the presence of acid in the system. Because if you put in a new compressor and there's acid in the system, okay, you're going to right away burn out that system again. Compressor replacement, as well as replacement of evaporator coil, condenser oil, or other system heat exchanger, is considered a major repair as defined by the EPA regulations. Guys, I want you to memorize this entire slide. Okay? If they ask you a question regarding what is a major repair, this is your list of things that are a major repair. And they ask it in a way where they toss in something like changing a filter dryer or changing a metering device. Do you see metering device on this list?
No.
Not a major repair. Do you see filter dryer on this list?
No.
Not a major repair. Okay? This is what they consider a major repair for Type 2. This is the only things they consider major repair. Questions? Okay, a deep vacuum is measured in microns. A vacuum level of 500 microns should be achieved to ensure all moisture and non-condensables have been removed from a refrigeration system. 500 microns is how you remove all moisture. Okay? Very deep vacuum. The water will boil off at like negative 20 or 30 degrees, okay? I mean, water, your boiling point drops way down in a vacuum. Water will just boil, so will any other liquids and stuff in there. Do not start a compressor while you're in a deep vacuum. Okay, by the way, that's a vacuum pump in front of you there. Okay, in the picture. Those are awesome. When evacuating a system with large amount of moisture, it may be necessary to break the vacuum by increasing the pressure with nitrogen to counteract freezing of the moisture. Water in the system can freeze if you use too large of a vacuum pump to evacuate a system. In other words, you drop that pressure too fast, water's not going to boil off. It's actually going to freeze. Okay, so what you do is you increase the pressure with nitrogen, and then you put it in a vacuum again. Okay, we call this like a triple vacuum situation, okay? We put a vacuum on it, we pull it down, then we put some nitrogen in the system just up to atmospheric pressure. We break the vacuum with that nitrogen, which is dry. There's no moisture in that nitrogen. And then we put it back in a vacuum, and we do this a couple times before we put it into this final vacuum. That allows us to remove any moisture without it freezing. If you use too large of a vacuum pump, again, you'll drop you'll pull it into a vacuum too fast, and moisture will freeze. We'll talk a lot more about that when we talk about Type 3. We really have to watch it in Type 3. If non-condensables such as air or nitrogen remain in a refrigeration system, the discharge pressure of the system will be extremely high. This is another slide. You need to know this entire slide. I think this is on page 23 of your book or something right around there. If non-condensables such as air or dry nitrogen remain in a refrigeration system, the discharge pressure of the system will be high. It will look like an extremely dirty condenser. And even if the condenser is clean, it's still going to act like a dirty condenser. Those non-condensables get stuck at the top of the condenser. They can't condense. Nitrogen tanks are under extremely high pressure. So nitrogen cylinders require a pressure regulator to reduce the pressure to a safe level. Okay, you're never going to use a nitrogen tank without a pressure regulator on it. Never install multiple pressure relief valves in series. If you're having a problem with a pressure relief valve going off and leaking, you can't install another one in series with it. Okay, you got to remove the original one and just replace it. Cannot install these things in series. Can only be installed in parallel. In an R410A chilled water system, okay, we charge vapor is charged from a vacuum level to approximately 110 psi. Okay, chilled water system, we have to charge with vapor first. Okay, 110 psi is about 36 degrees Fahrenheit, which will prevent the water from freezing on the water side of the system. Okay, be very, very careful with chilled water systems. If you charge them with large amounts of liquid refrigerant, you will freeze the water on the water side of the system. Okay, again, the saturation pressure of 410A machine at 80 degrees Fahrenheit at room temperature while the machine is not running is about 238 psi when referring to a pressure temperature chart. Okay, but again, the most important thing on this slide is on a chilled water system, we charge with a vapor until we hit about 110 psi because that's above the freezing point of water. At that point, I can start charging with a liquid. A 134A chiller should be charged with a vapor approximately 30 psi, which corresponds to a temperature of 35 degrees. That's because at 0 psi, the evaporation temperature of 134A is negative 15 degrees. And if you get any questions on this, all you have to do is remember, we do not want to freeze water. So look at your temperature pressure chart and find out where the water freezing point is. And our pressure that you're looking for is going to be the one that's slightly above that. For 123, it's a low pressure refrigerant that's used in low pressure appliances. Again, now we're talking low pressure. The evaporator runs under atmospheric pressure. 35 degrees is approximately 19.5 inches of vacuum. Okay, does everybody see the difference right here? We've sort of drawn a line. Low pressure appliances. The evaporator runs under atmospheric pressure. It's a very important distinction. Low pressure appliances. The saturation pressure of R123 is about 35 degrees at 19.5 inches of mercury. Does anybody have a question on that? ASHRAE standard 15 require, yeah.
I'm sorry, I was just curious, how do you, it doesn't specify how you charge on that one or what the difference is there.
I'm gonna talk about that in type 3 when we talk about low pressure.
Okay.
You're right, it didn't. Okay. ASHRAE 15 requires the use of sensors to detect the presence of refrigerant with a few exceptions. It does not require an equipment room refrigeration detector for R717, provided the mechanical ventilation system in the machine room is run constantly. Guys, again, a slide you need to memorize because they're going to ask you a question on this, and they're specifically going to reference R717. If there's a constantly running mechanical ventilation system, constantly running, okay, 24/7, you don't have to have equipment room refrigeration detectors. If it's a not constantly running system, if there's no ventilation, you have to have refrigerant room detectors. Okay, very few exceptions to the rule. Questions on type 2? Okay, guys, we got to talk about type 3. Now, type 3 is where a lot of people have problems on this exam. Okay, type 3, we're going to continue our type 3 conversation on Monday, but I'm going to start it, or on Tuesday, because Monday's a holiday, but I'm going to start it now. Okay, type 3, what I want you guys to remember, the evaporator of a type 3 system runs under atmospheric pressure. Yeah.
Do we have class on Monday?
No.
Okay.
No, that's what I said. Monday's a holiday. Well,
okay.
I caught myself. Monday's a holiday.
Is that a big compressor in the middle?
This is a big chiller. Now, let me tell you a little bit about what's going on here. Okay? Type 3 systems, the evaporator, which is the chiller barrel, okay, which is probably this portion right here. I can't see all the piping, okay? But the evaporator, which is the chiller barrel, okay, has refrigerant in tubes in here. We talked about a tube-in-tube chiller. Your tubes are accessible by taking all the bolts off the end after the thing's drained and refrigerant is recovered, okay? You have a big centrifugal compressor up here. This is an open drive compressor. Your drive motor is in this whole big container right here, okay? So we have a motor in here connected with a shaft to my centrifugal compressor. Suction line, okay? Now, controls are usually digital at this point. These things are humongous. Okay, the last one I worked on that I had to go work on, I'm pretty tall myself. I had to get a step ladder to actually get up into the motor area up here to check some connections on a motor. Okay, these are usually running 480 volts, 720 volts, that type of voltage. All three-phase, separate oil pump in here. There's an oil pump motor over here, separate control for the oil pump. Okay, very, very, very heavy compressors used in major office buildings, used in a lot of the hotels that have a central cooling system, used in major hospital buildings. Okay, these are chillers. There's usually 2 or 3 of them lined up in someone's basement, and you have cooling towers outside. Okay, but again, my key point is here to everybody, as we talk about type 3 systems, I want you to remember the evaporator, the low side of the system, is operating below room or atmospheric pressure. Now, our primary concern with type 3 systems is the fact that air and non-condensables leak into the system if we have a leak. They don't leak out. Okay? And chillers are notoriously leaky. Okay, so we have to deal with that air and non-condensables on a constant basis. So that is what we really want to worry about with type 3 system. Your refrigeration system is still basically the same idea, but air is leaking into the system instead of refrigerants leaking out. And we have to deal with the air at all times. That is the biggest difference. So when we talk about type 3 certification, we talk about leak detection. We talk about leak repair requirements. We talk about recovery techniques. We talk about recovery requirements. We talk about recharging, and then we also have to talk about safety. Now, here's a key to type 3. Type 3 can still ask you questions about core. They will not ask you questions about type 1 or type 2. Every type can still go back and ask questions about core, because the core requirements don't change. You still have to worry about safety. You still have to worry about shipping. You still have to worry about filling refrigerant recovery cylinders. All of that stuff still stays the same. Okay, so every single type can still throw in questions about core. You also have to pass core. So you will do fine with type 3 if you remember our primary concern is that non-condensables and moisture leak into the system, and we're working in a vacuum. Again, technicians maintaining, servicing, repairing, or disposing of low-pressure appliances must be certified as a Type 3 technician or universal technician. Most low-pressure appliances are used for comfort cooling, and they're subject to a lower allowable leak rate. Because a low-pressure system operates below atmospheric pressure, it operates in a vacuum. Leaks in the gaskets or fittings will cause air and moisture to enter the system. That's what I said earlier. Low pressure, we're worried about leaks entering the system. A low-pressure chiller requires a purge unit because they operate below atmospheric pressure. The primary purpose of the purge unit is to remove non-condensables that leak into a low-pressure chiller. Again, we have an extra part of the system on a low-pressure chiller. It's called a purge unit. It has one purpose, to remove the non-condensables that leak into a low-pressure chiller. And what you're looking at here on the screen is a purge unit. The purge unit gets its suction from a connection at the top of the condenser where most non-condensables accumulate. That is a question on your Type 3 EPA exam. The purge unit gets its refrigerant pulled out of the top of the condenser. After separating the air from the refrigerant, the purge unit sends the refrigerant back to the evaporator. Guys, let me repeat this. The purge unit pulls its suction side from the top of the condenser. After separating air from the refrigerant, the purge unit sends the refrigerant back to the evaporator. So basically, the purge unit, for the amount of refrigerant it pulls, it bypasses the entire condenser metering device, and it goes directly back to the evaporator. It has the pressure differential. It helps the purge unit work properly. High head pressure indicates an air leak in a low-pressure system and that the purge unit may not be operating properly. Again, high head pressure, which is my high side pressure, tells me that there's non-condensables in the system. I either have a leak that's too big for the purge unit to handle, or the purge unit isn't operating properly. Excessive running of a purge system on a low-pressure chiller generally indicates a leaking system. High-efficiency purge units will discharge a low percentage of refrigerant with the air they remove. Folks, this is important. That's why it's in red. High-efficiency purge units will discharge a very low percentage of refrigerant in the air that they remove. Okay, purge units. A hydrostatic test kit is used to determine if a tube is leaking. What is a hydrostatic test kit? Okay, if you look here on this picture right here, I have a spot for a connection, right? So I connect my nitrogen right there. I put this into the chiller tube I'm worried about after it's recovered and isolated. I can pressurize that tube and make sure the pressures don't drop. Leak testing a low-pressure refrigeration system with a nitrogen in the excess of 10 psi can cause the rupture disc to fail. Now, we haven't talked about what a rupture disc is yet. A rupture disc is another component on a low-pressure system. It basically replaces a pressure relief valve. A rupture disc is found on the evaporator of a low-pressure system. It makes sure the pressures do not go in excess of a certain psi. Okay, and make sure we don't overpressurize that system. Once a rupture disc fails, it releases all the refrigerant in the system to the air. They have to be replaced. They're not manually resettable. They have to be replaced. Then the 10 psi is important. Do not pressurize a system, a low pressure system with more than 10 psi. That rupture disc will fail. Charged low pressure refrigeration machines may be most efficiently leak checked by adding heat with circulated hot water or heating blankets. If I heat the water circulating through it, or I put heating blankets onto the chiller barrel, I can raise the pressure of that refrigerant safely. Okay, and again, leak detection. This is going to be on your exam. Charged low pressure refrigeration systems may be most effectively leak checked by adding heat with circulated hot water or heating blankets. To reduce refrigerant loss from the purge unit on an R123 system chiller, always leak test and repair the chiller. A low-pressure refrigeration system could have a leak if in the condenser or chiller barrel tubes if you find excessive moisture in the purge unit. Guys, again, water is going to leak from the chiller tubes, from the water side of the system, into the refrigerant if there's a leak in the condenser or chiller barrel tubes. The pressure of the water is actually higher than the pressure of the refrigerant. So the water is going to leak into the refrigerant, unlike the other systems that we talked about when we talked about water-cooled condensers, okay, where the refrigerant will leak into the water. This way will be reversed because the refrigerant pressure is under the pressure of the water. Any questions on this? To prevent air accumulation into an idle low-pressure system, okay, in other words, if I've mothballed it, if I've shut it down for a while, I can put the pressures, I can add pressure to it to bring it slightly above atmospheric pressure. Not over 10 psi above, but slightly above atmospheric pressure. What that allows me to do is it allows me to make sure I'm not pulling moisture into a system, because moisture in a refrigeration system is bad. Moisture most frequently enters the refrigeration system in low-pressure chillers through leaks from areas with gaskets or fittings. Guys, gaskets leak over time. Okay, these chillers, they could be in place for 20 or 30 years. Sooner or later, these gaskets are going to leak and need to be replaced. But anytime you have a leak in a low-pressure chiller, you've got to start checking the gaskets and the fittings, because that's where it happens. To check for leaks to the water side of a chiller, you can place a leak detector probe in the drain valve opening of the water box. Basically, that means the water side of the chiller barrel after you remove the water. So in other words, I can put a leak detector in the drain valve of the water side of this. And if I put a leak detector in here, it's an enclosed enough space where I'll be able to detect if there's a refrigerant leak. But you guys got to do it after the water's removed. Okay? If you try putting a leak detector probe in there with water in there, you've broken your leak detector. Drain the water sides of the evaporator and condenser prior to recovering refrigerant if it has a leak. Okay? If you suspect that there's a tube leak, The refrigerant has to be recovered to fix that leak, but you got to drain the water first, because that way your recovery machine doesn't pull water in from the leak. Okay, again, the water pressure is higher than the refrigerant pressure. We don't want to pull water in. Low pressure refrigeration systems with open drive type compressors. You got to check the shaft seal. This is an open drive. I have a motor, okay, that's here, and I have a connection to the compressor with a drive. I showed you this on another picture earlier. Open drive compressors leak around the shaft seals. According to ASHRAE Guideline 3, the system should be checked for leaks if, during a standard vacuum test, the pressure in a system rises from 1 millimeter mercury to a level above 2.5 millimeter mercury. Okay, everything else we've done has been talking about inches of mercury. Type 3, you're talking about millimeters of mercury. Just be very aware of that, because they're going to do that on a multiple choice question. Type 3 is the only one we've been talking about millimeters of mercury. The EPA leak repair requirements apply to all appliances using a regulated refrigerant. Once the threshold leak rate has been exceeded on any system using an ozone-depleting refrigerant with a charge of 50 pounds or greater, the owner must repair the appliance to bring the leak rate below the threshold, and they have to retrofit or retire the appliance. As of January 1st, 2019, the maximum acceptable leak rates are 10% of the charge per year when used for comfort cooling, 20% of the charge per year for commercial, and 30% of the charge per year used from the industrial. This is the same numbers as you have in Type 2. Nothing has changed. Same numbers as you have in Type 2. Chillers generally belong to the EPA leak repair category for comfort cooling. However, if used in multiple categories, the applicable leak rate is by the highest percentage of use. And there's an example here. If a company uses 55% of its chiller capacity in one of its manufacturing lines and 45% of it in the air conditioning of the office space, the chiller is considered the industrial leak rate category. If it would be the other way around, it would be considered the cooling or the comfort cooling. Highest percentage of what it's doing. Questions on this? Using the charge.
How would you figure that out, though? Like, if you go into an industrial place, how do you figure out which side of their production line is using the most? How do you determine if
honestly, first of all, most often, if you're if you're going to deal with one of these big chillers, you've been there a number of times before. Okay, you're not just a new guy. And if you happen to be a new guy who's on call, most often the people in the building are very knowledgeable. You'll be with somebody who's their mechanical person or something like that. Someone will be with you. And they're very knowledgeable, and all you have to do is ask, what does this chiller serve, is my first question. I don't even talk about leak repair requirements. All I say is, what does this chiller serve? And they will tell you. Okay, if it serves a production line, if there's a major manufacturing thing, like it's an ice plant, okay, where they make ice cubes and stuff like that, 9 out of 10 times it's going to be industrial, because that's the largest use. Okay, the one they use as the example on questions a lot of times is a skating rink. Okay, ice skating rink. That's not comfort cooling. That's industrial. That's the one they use most often. Okay. Again, we use the charge that's stated on the equipment nameplate for chillers. Okay, it's usually very easy because it is a complete package with all the refrigerant right there. The leak rate of an appliance using an ozone-depleting refrigerant must be calculated when topping off or recharging a system due to a loss of charge. Okay, again, we do have to look at it. We do have to say, am I charging more than the acceptable leak rate? Okay, because if we charge more, we have to put a plan in action. If an appliance with 50 or more pounds of a regulated refrigerant has exceeded a leak rate, okay, the owner has 18 months to retrofit or retire the appliance. If a replacement appliance will use a refrigerant that's exempt from the venting prohibition. This is the same requirement as type 2. Okay? They're trying to encourage owners to go to refrigerants that are exempt from the prohibition of venting. In other words, the carbon dioxide refrigerations and some of the other ones we don't have to recover, using the safer refrigerants. Not having a certified technician available cannot be used as a reason to extend the appliance leak repair deadline. Okay, they put this again in red print because it's important. Not having a certified service technician available does not excuse them from meeting the leak repair deadlines. System mothballing does not require removing the appliance and storing it in a warehouse at the facility. Okay, you can mothball an appliance right there while you're using it. Okay, it does not require removing the appliance and storing it in a warehouse. Okay, it can be mothballed in place. If an appliance containing 50 or more pounds of an ozone-depleting refrigerant has exceeded the threshold leak rate, the owner or operator has 30 days to repair the appliance. Okay, so that it leaks below the threshold and conduct the initial verification test. If a chiller with 200 or more pounds of ozone-depleting refrigerant has passed the initial verification leak, a follow-up test has to be conducted within 10 days. Folks, these are the same requirements as type 2. There's nothing different here. Okay, if it's over 200 pounds, we do an initial test and there has to be a follow-up test completed afterwards. The owner or operator of the equipment is responsible for and must keep all records of leak inspections, initial verifications, and any completed leak repair and follow-up verification tests for 3 years. EPA can come in and audit for 3 years. This is the slide we're going to leave off on for today. Does anybody have any questions about anything I covered today, especially about type 3? I didn't get a lot of questions on type 3, which makes me nervous. Anybody have any questions? Remember, we do not have class on Monday. Anything that's due today, try to get turned in by midnight tonight. It's sort of important. But we do not have class on Monday. I will see everybody on Tuesday morning. For those who are wondering, I'm scheduling EPA exams. I'm releasing a list of students to the instructors probably this afternoon. They should be starting to contact you individually after Tuesday. Okay, to make an appointment for you to take the testing one-on-one. It's going to be a Zoom testing session, okay, where you'll be required to have your cameras on and your sound on. There's a reason for that, okay? Quite honestly, it's not our decision. If I had it to do, I'd put all of you on one testing session. I'd do it all at one time. I cannot do that, okay, because EPA and ESCO have said we have to maintain the recordings of those Zoom sessions for 1 year. Okay, they just want to make sure no one's helping in the background is what it comes down to. Okay, so again, we're going to start getting these set up, but I couldn't have it set up before we know when we are finishing. Now, officially, this course ends on May 29th. Okay, I will probably extend it because I'm going to be the instructor of your next course as well I'm probably going to extend it by 1 or 2 days to give everybody time to take their EPA tests, and I do want to cover heat pumps, okay, because I think that's really important to talk about. So because of the fact testing and everything going on, I will probably extend that by 1 or 2 days. If you guys do well on your EPA exams, I'm going to use that as the final exam. Please do good on your EPA exams. I really don't feel like doing another final exam for you guys. So does anybody have any questions for me?
So, Chris, for me, it's Eric again.
Yeah.
These other instructors.
You got to say that again. I'm sorry, Eric. I missed part of that. Someone cut in on you.
I said, for me not being in school anymore, do you just plug me in with any instructor that's available then?
Yeah, what I'm doing is I have a student list which includes you guys, okay? You guys who graduated. And I'm going to be breaking that up among a number of instructors who are going to be contacting you guys to set up testing sessions. When they contact you, please let them know when you're going to be available uninterrupted. In other words, we don't need if you have kids or anything like that, we need someone else to be available with the kids. We can't have interrupted sessions.
Yeah, that won't be an issue at all.
Okay, but again, some people do have that issue, and I just want to say that. So, yeah, I got your information, Eric. I got the information from your whole group.
Okay, sounds good. And then, if I'm not mistaken, you have 3 times to take the test if you're not happy with your first one?
As long as anything you fail, you can retake, but it will have to be done with the same instructor, okay? Because once they put you into a session, you're going to have to make appointments for retake with the same instructor.
Okay. Okay.
Do me a favor, Eric. Pass it on your first time.
Oh, well, I plan on it.
No one looks at the grades. They're just looking at the pass-fail.
Okay.
And, Chris,
yeah.
I know you would have probably said it if you had any information, but I figured I'd ask anyways. Is there any idea on time period for lab time coming up at all for any of the schools?
I was actually supposed to have a meeting with my boss, who's Dr. Phil Krebs, this afternoon at 12 o'clock, and I thought I was going to bring that up on our call, but he seems to have taken off without telling me that we didn't have a meeting today, and we'll be back on Tuesday, so I won't have any more information before Tuesday. I can tell you that they've been ordering personal protective equipment to get it on the campuses, masks and stuff like that. That's all I know at this point.
Okay, because I know that I don't know about the other states, but I know that Massachusetts, which was very strict,